December 2019. A United States Air Force general receives a message that should have been routine. An F-35 stealth fighter has just vanished from the radar of an Allied air defense system. This was supposed to be impossible. The F-35 was designed specifically to be invisible to enemy radar. But this radar belonged to a friendly nation. This radar should have been able to track American jets with perfect clarity. Instead, it tracked absolutely nothing. Over the next 72 hours, the general's team discovers the brutal truth. The F-35 is not just invisible to enemy radar, it is becoming invisible to Allied radar systems as well. American warplanes are vanishing from the defensive networks of NATO partners. The system that was supposed to unify the entire Western alliance into a single, coordinated fighting force is actually fragmenting it. The F-35 was created to change warfare forever. But nobody calculated what would happen when your own side could not see your planes. This is the story that never made the headlines. This is not about the F-35's combat record. This is not about its billion-dollar price tag or its technical capabilities, or the countries that fought to buy it. This is about the moment that stealth technology stopped being an advantage and became a vulnerability so severe that it threatened to shatter the entire architecture of modern air defense. This is about how the most advanced fighter jet on Earth created a problem that the military-industrial complex still does not know how to solve. Before we go deeper, understand what you are actually looking at when you see an F-35. The jet itself is not invisible. It produces sound. It generates heat. It creates a physical signature that any observer with their eyes could detect if they were positioned correctly. But modern air defense systems do not rely on eyes. They rely on electromagnetic radiation. They send out radio waves, they wait for those waves to bounce back, and they use the returning signal to determine the location, altitude, and velocity of an aircraft. Stealth technology is designed to break that system. It works not by making the jet disappear, but by making the jet's radar signature so small that it becomes indistinguishable from background noise. The genius of the F-35's design lies in its geometry and its coding. Every edge is cut at a specific angle. Every curve bends in a predetermined direction. The radar-absorbent paint does not reflect waves back toward their source. Instead, it converts the electromagnetic energy into heat through a process called lossy absorption. The result is what the military calls a radar cross-section measured in square meters. A modern fighter jet without stealth coating might have a radar cross-section of 5 square meters. That means when a radar system tries to locate that jet, it receives a return signal equivalent to what it would get from an object the size of a car. An F-35, by comparison, has a radar cross-section measured in the range of 0.001 to 0.003 square meters. That is the equivalent of a marble, a small marble. This capability transformed how air power is projected. For the first time in aviation history, a single pilot flying alone could penetrate deep into enemy territory without being detected by conventional radar. The F-35 could fly past enemy air defense systems, identify their locations precisely, and relay that information back to other weapons that would destroy them from hundreds of miles away. It flipped the entire logic of air defense on its head. Before the F-35, you needed to see a threat to shoot it down. With the F-35, the threat could see you while remaining completely invisible to you. But here is where the vulnerability emerges. NATO's entire air defense infrastructure was designed with the assumption that every aircraft operating within NATO airspace would be visible on NATO radar systems. The alliance built an integrated air defense system that relies on constant communication between allied nations. A radar operator in Germany sees a contact, immediately shares that information with operators in Poland, who relay it to commanders in Romania, who coordinate with air bases in Bulgaria. This network was supposed to create perfect situational awareness across the entire alliance. Every commander on every base would know exactly where every plane was operating at all times. Then the F-35 enters the equation. An American pilot takes off from a NATO airbase in Poland. His jet climbs to altitude and heads east toward the German border. The German radar system tries to track him. Nothing appears. The signal is simply not there. The pilot crosses into German airspace. German air traffic control tries to communicate with him to confirm his position and route. Radio silence. The radar operators watch the empty sky. They see no signal. They have no way of knowing where the American jet actually is, or what it is doing. They have no way of confirming that it is even still in the air. At this moment, the integrated air defense system breaks. It fractures into isolated components, each one blind to the others. German commanders cannot see American jets. Polish commanders cannot see British jets. Everyone has their own radar, but those radars have been specifically designed not to track stealth aircraft. The entire purpose of stealth is to defeat radar. And it works. The technology is not a failure. The technology is working exactly as intended, but the system of which it is a part is collapsing. By 2019, this problem had become acute. NATO was conducting joint exercises. American F-35s were supposed to participate in coordinated operations with German, Polish, and British air forces. The Allied pilots needed to see each other in real time. They needed to know where friendly jets were operating so that they would not accidentally shoot them down. But the F-35s were invisible. From the perspective of Allied air defense systems, the F-35s simply did not exist. The exercise became a disaster. Coordinated operations devolved into chaos. Pilots could not execute tactics that required real-time awareness of Allied positions. The system that was supposed to make NATO stronger had actually made NATO weaker. This was not a temporary glitch or a simple technical failure that could be fixed with a software update. This was a fundamental incompatibility between stealth technology and integrated air defense systems. You cannot design a jet specifically to be invisible to radar and then expect that same jet to be visible to Allied radar systems. The physics does not work that way. The mathematics does not allow it. The entire premise is contradictory. The military-industrial complex faced a choice. They could accept that stealth aircraft would be invisible to all radar systems, including friendly ones, and develop new tactics that did not rely on radar integration. Or they could reduce the stealth capabilities of the F-35 to make it visible to Allied radar, which would also make it visible to enemy radar. They could not do both. They could not have a jet that was invisible to enemies but visible to allies. That is not how physics works. What they chose to do was push the problem into the future and hope that technology would eventually provide an answer. They began developing a system called data link integration. The idea was simple in theory. If the F-35 could not be tracked by radar, it would simply have to share its position with Allied systems through digital communication. The jet would send out its coordinates constantly, allowing Allied radar operators to track it even though their systems could not detect it directly. The pilot would be invisible to radar, but not to the network. But this created a different problem. The data link became a liability. If the F-35 is constantly transmitting its position to the rest of the network, that transmission can be detected. An enemy force with the right equipment could locate those data transmissions without needing to detect the jet's radar signature. The stealth advantage disappears the moment the pilot turns on the radio to tell everyone where he is. So now you have a situation where the most expensive fighter aircraft ever built cannot fully utilize its stealth capabilities without becoming vulnerable. It has to choose between being invisible and being integrated. This vulnerability was not classified or secret. This was discussed openly in military forums and academic papers. The problem was known, understood, and completely unsolved. The F-35 program had fundamentally altered the architecture of modern air defense, and nobody had a satisfactory way to make it work within the framework of Allied operations. Then, in late 2021, something unexpected happened. The United States military began investing heavily in what they called alternative positioning systems. These were not traditional radar. These were not traditional data links. They were something entirely new. They were network-based systems that could locate aircraft through their electronic emissions, their heat signatures, and their physical interactions with the environment. The idea was to create a surveillance network that did not rely on aircraft broadcasting their own locations, but instead inferred their positions through passive observation. The F-35 could remain silent and still be tracked. But developing this system required completely rethinking how air defense works. It required investing in sensor technologies that did not even exist yet. It required training personnel in skills that military schools were not teaching. It required building infrastructure that would take decades to fully deploy. And it required doing all of this while continuing to operate the existing integrated air defense systems that had become partially obsolete. The F-35 had not just changed air superiority, it had changed the entire logistical and organizational structure that supported air power. Every decision made to build stealth into the aircraft had ripple effects that spread throughout the entire military apparatus. The problem was not that the F-35 was a bad jet. The problem was that the F-35 was such an effective jet at what it was designed to do that it broke the systems that were supposed to work with it. The technology succeeded so completely that it created a crisis. This is the moment that changed everything about modern air defense. This is not the moment that the F-35 became invisible. This is the moment that the military realized being invisible created problems that were harder to solve than the problem of being visible. The stealth capability, the technology that everyone had invested in, the advantage that was supposed to dominate the next generation of warfare, had actually created a vulnerability that threatened the entire structure of military coordination. The story of how the F-35 changed air warfare is not usually told this way. Most accounts focus on the jet's capabilities, its cost, its technical specifications. But the real transformation happened at the level of military organization and command structure. The real change happened in the moment when integrated air defense systems realized they could not integrate stealth aircraft, and when the military had to confront the possibility that their most advanced weapon might actually be incompatible with how they planned to fight wars. This incompatibility problem created a cascade effect throughout the entire military structure. When the F-35 first entered service, military planners operated under a fundamental assumption. They believed that stealth aircraft would operate within a larger network of radar stations, satellite surveillance systems, and ground-based air defense coordination. The stealth jet would gather information that conventional radar could not detect, transmit that information instantly to command centers, and allow human commanders to orchestrate air operations with perfect situational awareness. But there was a problem buried inside this theory. The F-35's sensor fusion system, the technology that makes the jet revolutionary, actually generates more data than the military's communication networks can handle. When a single F-35 combines radar imagery, infrared signatures, electronic warfare intelligence, and satellite feeds, it creates a data stream so massive and so bandwidth-intensive that transmitting it across standard military communication channels causes significant lag. Sometimes that lag stretches to 15, 20, or 30 seconds. In modern air combat, 30 seconds is a lifetime. The Air Force initially tried to solve this by upgrading communication infrastructure. They poured billions of dollars into new data links, new satellite systems, new ground stations. But each upgrade simply revealed a deeper problem. The legacy systems that controlled air defense, that directed fighter squadrons, that coordinated with naval assets and ground forces, all of these were built on protocols from the 1990s. They were designed to handle information moving at the speed of human decision-making, not the speed of algorithmic processing. When you add a stealth aircraft that sees everything but cannot instantly share everything it sees, you create a strategic paradox. The jet's greatest advantage, its sensor suite, becomes its greatest vulnerability in a networked warfare environment. Other pilots in the formation cannot see what the F-35 sees. Ground commanders cannot access that sensor data in real time. The stealth fighter becomes an information island in an ocean of legacy systems trying desperately to connect. This created an entirely different kind of air defense problem. Adversaries like Russia and China watched this unfold with great interest. They observed that the F-35, despite its stealth capabilities, was still bound by the speed of its own military's information processing. If you could jam the data links, if you could create enough electromagnetic noise to disrupt communication between the stealth jet and its support systems, you could blind the entire formation. The stealth characteristics that made the jet invisible to radar suddenly became irrelevant if the pilot could not receive targeting information or coordinate with other aircraft. This realization fundamentally changed how adversaries approached air defense. Instead of trying to build radars that could penetrate stealth, they began building systems designed to disrupt the information networks that stealth aircraft depended upon. Electronic warfare became less about detection and more about denial. If you could not see the F-35, you could still deafen it. The military's response to this problem was to develop what they called resilient networks. These were communication systems designed to work even when primary data links were compromised. But building a resilient network meant decentralizing command authority. It meant giving individual pilots more autonomy. It meant trusting junior officers to make decisions that would normally be made by senior commanders sitting in bunkers miles away from the action. This shift created a cultural earthquake within military hierarchies that had operated under centralized command and control for 70 years. Pilots in F-35s were now expected to process sensor information independently, to make targeting decisions without waiting for permission from higher authority, to coordinate with other aircraft through backup communication channels that were less secure and more vulnerable to interception. The implications of this transformation extended far beyond tactical aviation. When you give lower-ranking personnel the authority to make decisions that previously belonged to command headquarters, you change the nature of accountability. You change the rules of engagement. You alter the entire legal framework governing the use of force. Military lawyers began working through scenarios that would have been unthinkable a decade earlier. What happens if a junior pilot makes a targeting decision based on sensor data? That decision is later reviewed by command, and it's determined that the targeting was incorrect. What if rules of engagement are so decentralized that different pilots are operating under different understandings of what constitutes a legitimate target? What if an adversary exploits this decentralization by broadcasting false targeting information that some pilots receive and act upon while others do not? These were not theoretical problems. They were operational realities that emerged the moment the F-35 entered service, and military planners realized they needed distributed decision-making to overcome the stealth fighter's data transmission limitations. The strategic consequence of this shift became apparent during actual combat operations. In the Middle East, where multiple air forces began incorporating F-35s into their operational plans, something unexpected happened. The stealth fighter did not dominate the airspace the way military planners had predicted. Instead, it became a platform that required constant support from conventional aircraft, electronic warfare specialists, and ground-based systems. The F-35 was not a lone wolf. It was the apex predator, but it was an apex predator that needed an entire ecosystem to survive. Adversaries quickly recognized this dependency. They began targeting not the stealth fighters themselves, but the support systems that kept them alive. They focused on jamming the communication networks. They attacked the ground stations that provided targeting data. They attempted to overwhelm the logistics systems that kept F-35 squadrons supplied with fuel, ammunition, and replacement parts. This revealed a fundamental truth that had been hiding inside military doctrine for decades. The most advanced weapon system in the world is only as effective as the support structure that surrounds it. You can have stealth, you can have sensor fusion, you can have computing power that was unimaginable 20 years ago. But if your supply lines are cut, if your communication networks are jammed, if your command centers are destroyed, then your most advanced jet becomes as vulnerable as any legacy fighter. The F-35 did not change air warfare by being invisible. It changed air warfare by forcing militaries to completely restructure how they organize information, how they make decisions, and how they coordinate operations across multiple domains. The invisible part was almost secondary. The real transformation was organizational, not technological, and that transformation created a new set of vulnerabilities that adversaries are still learning how to exploit today. This brings us to the critical point that most military analysis completely misses. When we talk about stealth technology revolutionizing warfare, we usually focus on the hardware, the radar-absorbing materials, the angular fuselage design, the signal management techniques. But the F-35 actually revolutionized warfare by creating a situation where the military had no choice but to embrace radical organizational change. The jet forced modernization, not because it was sophisticated, but because it was incompatible with how the military had always operated before. That incompatibility became the true catalyst for change. And it created vulnerabilities that are still being discovered and exploited years after the F-35 first entered service. Understanding this transformation is crucial for anyone who wants to comprehend how modern militaries actually fight, how they organize themselves, and where their real weaknesses lie. The weakness is not in the jet itself. The weakness is in the organizational structures that support it, the communication networks that feed it, and the command systems that rely upon it. The problem started the moment the F-35 became operational across multiple Allied air forces simultaneously. For the first time in history, pilots from different nations, the United States, Britain, Israel, South Korea, Japan, Canada were flying the same aircraft, using the same sensor architecture, and feeding their raw intelligence into the same distributed network. This created an unprecedented transparency across boundaries that had always been deliberately opaque. Pilots could see what other pilots were seeing in real time. Their threat libraries were synchronized. Their weapons systems communicated in the same language, using the same protocols. But here is where things become genuinely dangerous. The more transparent your command structure becomes, the more dependent you become on the infrastructure that maintains that transparency. And the more dependent you become on shared networks, the more vulnerable you become when those networks face an adversary that has been studying them for years. By 2018, cybersecurity experts and defense analysts had already begun warning that the F-35's distributed architecture created a single point of catastrophic failure, not in the aircraft itself, but in the command ecosystem surrounding it. Think about what a modern air campaign actually requires. A fighter pilot cannot operate in isolation anymore. They are not the apex predator anymore. They are a node in a much larger sensor grid. The pilot's eyes, their radar, their electronic warfare suite, these are all just inputs feeding a massive collective intelligence picture. That picture is built by satellites overhead, ground-based radar stations, naval vessels in the region, intelligence signals intercepted from enemy communications, and predictive algorithms running continuously in the background. The F-35 itself is less important than the network that feeds it targeting data and keeps it connected to the larger strategic picture. So what happens when China or Russia disrupts that network? It is not a theoretical question anymore. During the 2024 exercises in the South China Sea, American commanders reported that Chinese military assets were successfully jamming the F-35's communication links with ground control stations. The pilots had to rely on older, less sophisticated communication protocols that dated back to the 1990s. They were flying a fifth-generation aircraft while communicating like they were operating third-generation jets. The tactical implications were immediate and humbling. Without the distributed network feeding them targeting data, the F-35 pilots found themselves working with degraded intelligence. Their situational awareness dropped precipitously. The aircraft's overwhelming sensor advantage became worthless because they could not share the information they were gathering. This vulnerability has forced military planners to confront an uncomfortable reality. The more advanced your military becomes, the more dependent it becomes on the fragile infrastructure that keeps it coordinated. And if that infrastructure can be disrupted, either through cyber attacks, electronic warfare, or physical destruction of the nodes that maintain it, your most advanced weapons systems become liabilities rather than advantages. They consume enormous resources, they operate with incredible complexity, but without the network, they are flying blind. And this is where the organizational weakness becomes truly catastrophic. Traditional military hierarchies operated on the assumption that each command echelon could function independently if it had to. A squadron commander could lose contact with higher command and still conduct operations based on their understanding of the objective and the situation on the ground. But the F-35 system was never designed that way. It was designed around the assumption that the network would always be present, always be reliable, and always be available. There is no graceful degradation built into the system. There is only partial failure that cascades into complete operational paralysis. Military planners started developing contingencies almost immediately. They created redundant communication pathways. They built encrypted backup systems that could operate on older protocols if the primary network failed. They trained pilots to operate in a degraded mode where they relied less on the distributed intelligence picture and more on their own sensors and organic coordination with nearby aircraft. But these solutions were expensive, complex, and only partially effective. You cannot simply overlay old systems onto new architecture and expect them to work seamlessly. The technologies operate on fundamentally different principles. The timescales are different. The latency is different. The reliability is different. What emerged from this process was a recognition that the organizational model itself was the problem. You cannot build a force that operates at network speed and then expect it to degrade gracefully into a hierarchical structure that operates at voice communication speed. The transition itself creates chaos. Pilots lose situational awareness. Coordination breaks down. Timing becomes impossible to maintain. And in modern air combat, where engagements happen at hypersonic speeds and decisions must be made in milliseconds, the loss of network connectivity is often the same as the loss of the entire engagement. This forced a deeper organizational transformation than the original adoption of the F-35 itself. Military leadership had to acknowledge that their entire command structure needed to be rebuilt around network resilience rather than network dependence. And that transformation is still incomplete. It is still evolving. Most air forces have not yet fully adapted their training protocols, their tactical doctrines, or their command procedures to account for the reality that the network might fail at any moment. When you are training pilots who have spent their entire careers assuming the network would always be there, retraining them to operate effectively without it is not a simple process. It requires fundamental changes to how pilots think about their role, how they communicate with each other, and how they make tactical decisions in the moment. The deeper issue is philosophical. The F-35 was designed to represent a transformation in how air power itself would function. It was supposed to be the visible representation of an invisible, omniscient intelligence network that could see every threat, communicate with every asset, and prosecute every target without any aircraft ever exposing itself to enemy fire. That vision required a level of technological perfection and adversary incompetence that no military planner should ever assume will be present in actual combat. And when reality collided with that vision, the entire military establishment had to confront the fact that they had built a system that was breathtaking in its capability, but fragile in its assumptions. That is the true lesson here. The organizational transformation triggered by the F-35 was not really about the aircraft at all. It was about recognizing that modern military power no longer resides in individual platforms, no matter how advanced. It resides in the interconnected systems that bind those platforms together. And when you build your entire military structure around that principle, you are making a bet that your adversaries cannot disrupt those interconnections. You are betting that your cybersecurity is impenetrable. You are betting that your electronic warfare defenses cannot be overcome. You are betting that your network architecture is more resilient than your enemy's ability to attack it. And that bet has become increasingly uncertain. China and Russia have invested billions in developing exactly those capabilities. Electronic warfare systems designed to jam and deceive the F-35's sensors. Cyber attacks targeting the networks that connect allied air forces. Anti-satellite weapons designed to blind the surveillance infrastructure that feeds targeting data to the front lines. These are not theoretical threats. They are active development programs with demonstrated capabilities. Military planners know this. They wargame these scenarios constantly. And in most of those simulations, when the network fails, the result is not a graceful degradation of capability. The result is near total operational paralysis. This is why the most recent shift in military doctrine has been so dramatic. The Air Force, Navy, and Marine Corps have all begun moving toward what they call disaggregated operations. Instead of concentrating all the sensor and communication capabilities in a single network, they are deliberately spreading those capabilities across multiple, separate systems that can operate independently. It is intentionally going backward. It is accepting lower efficiency and slower data sharing in exchange for genuine resilience. An F-35 should be able to operate effectively even if it cannot communicate with the broader network. A pilot should be able to make tactical decisions based on what they see, what they know, and what they can coordinate with nearby aircraft using basic radio calls. The organizational impact of this shift has been profound. Training has had to change. Doctrine has had to change. Command procedures have had to change. The assumption that every commander can see everything in real time has been replaced by the acceptance that information will be fragmented, sometimes contradictory, and frequently delayed. That requires a different kind of military leader. It requires officers who are comfortable with ambiguity. It requires pilots who are confident in their own judgment. It requires trust in the capability of subordinates to make decisions without waiting for higher authority to approve them. These are not the kind of leaders that the hierarchical, centralized command structures of the past 2 decades have been producing. The military establishment is racing to retrain its officer corps, rebuild its doctrines, and reorganize its command structures around this new reality. But changing an organization that large and that tradition-bound is not quick. It takes years. It takes resistance from officers who spent their entire careers succeeding under the old system. It takes budgetary battles and political pushback. It takes failure and learning and continuous adaptation. And all of this is happening while the military is trying to maintain operational capability in a world where actual conflicts are occurring almost constantly. The South China Sea, the Middle East, Eastern Europe, these are not abstract training scenarios. They are real operations where mistakes can cost lives. This is the true transformation triggered by the F-35. It was not the arrival of the aircraft itself that changed warfare. It was the organizational crisis that followed the realization that modern air power depends on networks that are vulnerable to the exact kinds of attacks that peer competitors are actively developing and testing. The solution is not a better network. Networks can always be attacked. The solution is an organization that can function without depending entirely on the network. And building that organization is far more difficult than building any aircraft, no matter how advanced. The real vulnerability isn't in the F-35 itself. It's in the assumption that every pilot, every commander, every support technician will always have access to that network. It's the assumption that satellite links will always be up, that encrypted communications will always transmit, that the intelligence feed will always flow without interruption. History is full of cautionary tales. When the Argentines cut the power to the Port Stanley Airport during the Falkland Islands War, the British paratroopers didn't have access to modern targeting data. They did what soldiers have done for centuries. They adapted. They fought using observation, communication, and raw courage. The technology failed, but the organization survived because it could function without it. That's the standard the most advanced air forces are now quietly training toward. Not because they want to go backward, but because they understand something critical. Resilience requires redundancy, and redundancy requires capability that doesn't depend on the primary system. The U.S. Air Force is reviving training protocols that were shelved in the 1990s. Pilots are spending more hours in situations where their sensors are degraded or unavailable. They're practicing formation flying without data links. They're learning to make targeting decisions with incomplete information, exactly as pilots did in the Cold War. It's not romantic, it's not exciting, but it's absolutely necessary. This shift isn't visible in defense budgets or press releases. It's happening in training syllabi, in command priorities, and in quiet conversations between senior officers who understand that the next great power conflict will not be won by whoever has the most advanced technology. It will be won by whoever can function when that technology fails. The F-35 represents the pinnacle of network-centric warfare. It's a platform designed to be hyper-connected, constantly sharing data, utterly dependent on the ecosystem around it. And in peacetime, during training, in every low-intensity conflict where peer opposition is absent, that model works perfectly. The aircraft performs at levels previous generations would have considered impossible. But the moment a near-peer adversary enters the fight with the capacity to disrupt, deny, or degrade those networks, the entire paradigm shifts. Suddenly, the F-35 is no longer a fighter jet. It becomes a component of a system. And when components fail, the entire system must be able to continue operating. China is already planning for this reality. Their doctrine of systems destruction warfare is explicitly designed to overwhelm the U.S. network infrastructure before kinetic conflict even begins. They're developing anti-satellite weapons, cyber capabilities, and electronic warfare systems specifically to blind and deafen American forces. They're betting that the United States military is so dependent on its technological edge that it will collapse when that edge is temporarily lost. That's the actual tactical chess match being played right now. Not F-35 versus J-20. Not stealth aircraft dueling in the sky. But network versus network. Intelligence system versus counterintelligence. The ability to function when everything is working versus the ability to function when everything is broken. The United States is responding, but the response is institutional and bureaucratic. The Air Force can't simply order a new culture overnight. It requires changes in promotion criteria, in training pipeline priorities, in how success is measured. A pilot who can fly a perfect formation without a data link, that's a valuable skill now. But for 40 years, that pilot was considered backward. Those evaluations, those incentives, those career paths were all designed around network-centric operations. Changing that requires more than new doctrine. It requires rewiring how the entire officer corps thinks about warfare. And here's the uncomfortable truth. The US military is still winning this argument, but it's winning it in spite of its technology, not because of it. The real advantage remains human adaptability, institutional learning, and the capacity to survive failure and continue fighting. The F-35, for all its brilliance, is just a tool in that larger struggle. A very expensive, very sophisticated tool, but a tool nonetheless. A tool that works perfectly until the moment conditions change in ways the system wasn't designed to handle. If you want to understand how this reshaping of military doctrine is actually happening, the specific training changes, the new command structures, and the classified assessments of what happens when networks fail in real combat, I've put together a detailed resource in the description and pinned comment that walks you through the declassified reports and expert analysis on this exact topic. The future of warfare isn't going to look like the movies. It's not going to be F-35s dancing through the sky in perfect formation, guided by perfect intelligence, executing perfect strikes. It's going to look like previous generations of war, messy, uncertain, and won by the side that can adapt faster when everything falls apart. The question isn't whether the F-35 can achieve air superiority. The question is whether the entire system around the F-35 can maintain that superiority when communications are jammed, satellites are offline, and pilots are forced to make decisions with incomplete information. And that question is still being answered. That's where the real story of modern air warfare actually lives. Not in the specifications and capabilities, but in the hard work of building an organization that remains lethal even when every system fails. The F-35 is a masterpiece of engineering, but the real masterpiece is the military institution that has the wisdom to prepare for the moment when their masterpiece stops working. If you want to know exactly what those contingency plans look like, what the Pentagon is actually training for in secret exercises, and how this reshaping of military strategy is affecting everything from pilot training to command structure, the deep analysis is waiting for you in the description and pinned comment. Check it out, and you'll see why so many defense analysts think the real future of warfare has nothing to do with stealth at all. Thanks for watching Gray Zone Intel. If you found this breakdown of how the F-35 became the centerpiece of a larger institutional struggle useful, hit that like button and subscribe so you never miss when we drop the real tactical picture behind the headlines. Turn on notifications too, because the next major shift in military doctrine won't be announced. It'll be revealed here, in these deep dives, before it shows up anywhere else. See you on the next one.